Hello, hello, favorite 7th graders. Today I want to teach you how to solve problems involving triangles' interior and exterior angles. Go ahead and make this the title on the next free page in your math notebook. When you have done that, you know the drill. Mark that page, close that notebook, activate that brain, concentrate, and I'll tell you when it's time to open it and write. So we have so far learned about triangles' interior and exterior angles. Let me remind you what we have learned. First of all, just draw your random triangle here. Interior angles mean inside. Those are synonyms. So the angles inside a triangle, I'm just going to make up what these appear to me to be. This might be about 80. This one looks pretty narrow, maybe 30. And to find this last one, I know that the interior angles of a triangle have to add up to 180. So if this one was 80, that was 30, that's 110. Am I right? That leaves another 70-degree angle. So in any triangle, the interior angles will always add up to 180 degrees. That is something we looked at 2 days ago. The exterior angles, exterior is a synonym for outside, those are formed if you take one of the sides of the triangle and extend it past the triangle. They're these angles outside the triangle formed by extending the sides. Like that's an exterior angle and that's an exterior angle. Obviously, if you know the angles in the triangle, you can figure them out because they make a supplementary set. So like this one's going to be 110 because 110 and 70 make 180. And this other one would have to be 100 because 180 make 180. That's one way, but we also learned an exterior angle theorem, which said this. For instance, the red angle, the exterior angle here, is also going to be equal to these two sides put together. The other two interior angles that it's not adjacent to as well. So those add up to 110. So that's another way to find out that this is 110. There's two ways to do it. So I can find out that it's 110 here. 70 plus 110 is 180. Or I can add these two to get that 110 as well. Same with the blue one. The blue one either is 100 because 180 makes a supplemental set, or I can just add the other two interior angles and I'll always get the same thing. 100. That can be hard to remember. That's called the exterior angles theorem, but it's going to be very important today because I'm going to show you some where that's the only way to do it. So let's get into problems with variables in them involving triangles. So this one involves interior angles of triangles. It says find the value of x, and I've got the three angles with variables here. So I want to find x, and I know all three angles. So I'm going to have to use a piece of information I know, which is that if I add all three interior angles together, their sum equals 180 degrees. So I'm going to use that fact here to say that this angle plus this angle plus this angle, those add up to, that's all three angles in a triangle, interior angles, so those should add up to 180. So setting up your equation often is the toughest part, and that's how I do it. Before I do any combining, let me add the opposite. Add the opposite. Subtraction causes problems. Now I can combine like terms, so we can combine the x's, 3, 4, 5, 6 x's, all positive. Can also combine the constants. Negative 17 plus 40 is what? Positive, is more positive than negative. So combine those. I think it's going to be positive 23. Did that in my head. You can verify on a calculator if I'm wrong. Plus another negative 5. That's 5 less than that. So that would be what? 18, I think. So if I added those correctly, should be 6x plus 18. Now I've combined all my like terms, and those are equal to 180 on the other side. I didn't really draw this in the right place, so I'll just redo my line. So I've combined like terms, and now I'm ready to solve for x the same old way. Minus 18. That is 162 equals 6x. And this one I'm going to calculate. 162 divided by 6 is 27. So x equals 27. Now, note that does not mean I have any 27-degree angles, but I wasn't asked for any of the angles. Sometimes I am. I was just asked for x. So that's an interior angles problem. They usually involve taking your three angles, adding them up to 180. Here's an exterior angles problem. Looks kind of scary. Take a look at it, and then I'll start to talk about it. So here I'm asked to find the value of x, but I don't have all three of the triangle. If I knew this interior angle, I could say x plus 20 plus whatever this one is equal 180, but I don't have that. So that won't help me. So let me tell you two ways you could solve this problem. There's two actual paths to victory here. Path one, you don't have to remember that external angles theorem, which can be hard to remember. You can use a supplementary first. So what I could do is say, well, I don't know this angle, but I can find it because it's supplementary with this 120. 120 and this one make a straight angle, 180-degree angle. So that means that one would have to be 60 because 120 and 60 make this 180-degree straight angle. So now then, so one is I can do that. I can say the missing angle is 60. So I found that with supplementary sets. And now I can use that 180 thing and say this plus this plus this is 180. X plus 20 plus 60 is 180. So that's one route to finding that. Find the missing angle, then add these up. And here we go. So now I've got 2x plus 80 equals 180. Take away 80. 2x equals 100. And x equals 50. So that's one path to finding that. There is another. If you remember that external angles theorem, you can solve this even quicker. If you remember, any exterior angle is equal to the other two interior angles added together. So if you remember the external angle theorem, then you have an even shorter path to the end. And I can just say, I know these two interior angles. When I add them together, I get the other exterior angle, the far exterior angle across from them. So that would be 2x plus 20 equals 120. And of course, I'm going to get the same thing I got here. Minus 20. And x equals 50. So either way works. You can just find this missing angle, then use the inside angles, or you can remember that theorem. All right, open your math notebook. Let's do one of each together. Pause here. We'll do an interior angles problem first and an exterior angles problem second. You'll smoke through both of them and have them both to refer to. Okay, so what is going to be important here is that the interior angles add up to 180 in any triangle. So if I take this angle plus this angle plus this angle, they add up to 180 because they are interior triangle angles. They always will equal 180. All right, so there's my equation. All that's left to solve it. Combine some terms. There are two x's. And all those, I'm just going to add those to the calculator so I don't take too long. 59 plus 84, all the constants, plus 51. Those add up to 194 together. I don't think that's right. Is that right? That is right. Equal 180. Take away 194. Ooh, I'm going to get something negative here, aren't I? So it looks like 2x equals negative 14, which means x equals a negative 7. Got it. So that's an interior angles problem. People don't tend to forget those. Those pretty good, tend to go well. Add those three up and you'll get 180. People tend to remember that. Next, we're going to do an exterior angles problem. Those people tend not to remember. So a lot of times they'll look like this. They'll give you exactly the three angles for the exterior angles theorem, and not this missing one. So when I did the I do here, we could use this to find this, and then use the inside angles, but this we can't. We're not going to be able to figure this out since there's a variable in it. Last time it just gave us a number. So what I'm going to have to remember here is the exterior angles theorem. Not terribly easy to remember. It tells me that this exterior angle should be these two other interior angles added together, not the one right next to it, the other two. So it tells me that the exterior angle, 18x plus 5, should be equal to these two interior angles added together, 46 plus negative 1 plus 8x. So you'll notice this is a tough one. We've got variables on both sides. That is one of our more challenging situations to solve the equation for. When that happens, I recommend the drawing strategy. You don't have to, but I highly recommend it. I've found it works better for folks. 18x, good night. I don't feel like drawing that many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. Oh, 18. Plus 5 is equal to, I'm going to combine these right away. I usually tell you not to do that. I'm going to do that now. 45 and 8x. So when there's variables on both sides, remember your method to get rid of that is to take whichever side has less. I usually choose. I'm just going to take all those away. So I'm going to take these 8 away here, and I'm going to take 8 of these away too to keep it balanced. And when I redraw, there will be 10 left. 5 and 45, and now this isn't a terribly tough one to solve. Remember, I want to go back to the question. All this stems from this theorem that this exterior angle is equal to the other two interior angles added together. That's the theorem. Oftentimes you don't have to remember that. On this one you did. Now I'm ready to take away 5. That's going to leave me with 40 here when I'm done, and 10 of these. So x would equal 4. Y'all, that is how you use the interior and exterior angles theorems to solve problems with variables in them. I hope this made a lot of sense to you. If it did not, please go back and double check this again, maybe even just the connect and remember those interior and exterior angles theorems. Knowing those facts is important and will help you do these. If this did make a bunch of sense to you and you think you could do it from here, you're all set, and I will see you next time.